Okay, in this video I want to mathematically show that you can double a light's wavelength as a circumference, and you can mathematically show that if you double the wavelength as a circumference, you can use these angular velocity formulas to mathematically show that a wavelength of light from an atom doubles as an electron orbit. And I can mathematically show that by using these angular velocity formulas. So we'll do let's see, what wavelength shall we do? We'll do 0.1, 2, 3, 4, 5, 6. We'll do 300 nanometers times the speed of light. 1, 2, 3. Oh, wait a second. It's the speed of light. It's the speed of light divided by wavelength equals frequency. Divided by 1, 2, 3, 4, 5, 6, 7. Okay, so here's the frequency of 300 nanometers right here. And according to these formulas over here, we take frequency, times it by pi, times it by 2. We should have the angular velocity of 300 nanometers. Okay, which is that. Okay, so now if we take 300 nanometers and double it as a circumference, 2, 3, 4, 5, 6, 7, and multiply it by 0.31831, we get this as the diameter for 300 nanometers. Divide that by 2. We get this as its radius. So now if we follow this formula over here, copy this number, take the speed of light, 300 million meters per second. Is that right? Alright, let's do this one more time. 1, 2, 1, 2, 3, 1, 2, 3. 300 million meters per second. And we're going to divide it by the radius that we just found, equals that. See the similarities between the two numbers? I just took this formula, found the frequency of 300 nanometers, and took this formula and got this number, and I took the velocity and I took the wavelength and I doubled it as a circumference, and by doubling the wavelength as a circumference I got an angular velocity of almost the same as using this formula. So if I multiply this number over here by the radius that we just found over there, we get almost the speed of light. We get 107.269 blah 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 over the speed of light. Okay, so now we can do it. We can do it for any amount of numbers. Let's try 0.1, 2, 3, 5, 6. Let's try 0.900 nanometers times the speed of light. 1, 2, 1, 2, 3, 4, 5, 6. Oh no, I keep doing that wrong. It's the speed of light divided by wavelength equals frequency. So we're going to do divided by 0.1, 2, 3, 4, 5, 6, 900 nanometers equals that as its frequency. So we'll times that by pi, times it by 2, equals that. Okay, so now we'll take the wavelength doubled it as a circumference, so we'll multiply it by 0.31831. That's its diameter. Divided by 2. That's its radius. Okay, so then we'll do speed of light. 2, 3, 4, 5, 6. Speed of light divided by radius that we just found. And it equals that. Remarkably almost identical. Again, using 900 nanometers as a circumference and as a wavelength, we use these two formulas over here for angular velocity, and we got almost the same identical number again. See, if we multiply this number by the radius that we just found, see, we get 300,000, 107, 269, blah 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 blah, 107, 107 over 300,000. So it's the same thing. Wavelength is the same thing as an atom's orbital circumference, and this mathematically shows it.